All right, so in our second video on forces of motion, we're actually going to step away from forces of motion for now, because we need to look at an idea called a gradient before we can start looking at things like speed and velocity and acceleration and stuff like that. So this is actually fairly crucial to understanding those later videos, which is why we do it now. So as with all the videos that I do, I'd like to start off by actually seeing what we currently know or what we would currently do. So first of all, I'd like you to have a think about what does the word gradient actually bring to mind? Maybe note it down on a piece of scrap paper. So pause the video. What does the word gradient bring to mind there? All right, so now you've done that, the second thing I'd like you to do on your scrap piece of paper is how would you describe this graph that you are seeing here? So let's keep it generic for now. Let's just say this has got some X and we've got some Y on here. How would you describe this graph that we're looking at here? All right, so now you've done that, we've got our kind of starting point for what we know about gradients and what we would do if we were describing this graph. So let's delve into, to start with, like what a gradient is, and then we will have a look at how we describe it. So when we have the word gradient, it's all about change or difference. Okay, so in the various contexts we come across it. So anyone who's done some kind of graphics design or tried to give themselves a background on PowerPoint, something like that, will know that there is a setting called gradient. And what that does is it slowly changes from one color into another, but without like a distinct breaking point. So you can see we're slowly changing from like this what's rosy coloured all the way into this pink and purple. So we've got gradient being used for like slowly changing from one thing to another. On the right hand side, out on the roads, you'll see signs like this, indicating how steep the hill is. So in that case, we've got an altitude change. So the first thing I think about is, so in my head, the word gradient is very closely tied up with the word change, and I actually can't think of any uses the word gradient which don't mean change or difference. So if you can think of some that I have overlooked or don't know, please do comment and let me know. I'd be interested in hearing about it. But in my head anyway, the word gradient means change or difference, essentially. So let's have a look about what a gradient kind of means and how we can describe it. So in physics, we use gradients to describe how steep a best fit line on a graph is. So very commonly, we'll do an experiment, we'll plot some data on a scatter graph, and we'll draw a line of best fit. And as part of our conclusion, we want to describe what we're seeing. And the gradient is a concept we use to enable us to fully describe what we're looking at. Okay, so the first thing we're going to use a gradient to do is describe whether it's going upwards or downwards. Okay, so that's where we will make the number, which is what a gradient is. A gradient is a number. So if the number is positive, that indicates that the line is going upwards. So as you go to the right on the graph, the best fit line is going upwards. So there's lots of different ways we can accomplish the line going upwards. So we could have a straight line, we could have it curving sort of sloping off, or it getting steeper and steeper. But all of those lines as you move towards the right are going upwards. So that means the gradient will be a positive number anywhere that we found it on those graphs. Okay, so that's the first thing I think it's worth writing down. What makes a gradient a positive number? Okay, so now we've got that written down, let's describe what makes a graph a negative number. And it should be hopefully not too surprising, it's the exact opposite. So if we describe the gradient as a negative number, that means that the graph is going downwards as you go towards the right on the graph there. So, and that's the same on each of these. Although they're different graphs, they're all going downwards as you move towards the right or look across towards the right there. So it's the exact opposite, essentially. So there are a couple of scenarios that avoid those two. So we can have a gradient of 0, which is neither positive or negative. That's just a horizontal line, so it doesn't go up or down as you go across the graph. And we can also get graphs where it goes up and then down, so it'll be then like positive and then negative gradient. But let's keep things simple for now. So that's the first thing. Our gradient number can be either positive or negative. That tells us about what, generally speaking, what the graph is doing. Then what can happen is the actual number itself can change. So on these graphs here, the number or that describes the gradient is actually changing as you move towards the right. So these graphs show a scenario where the gradient is increasing. So the number is getting bigger and bigger and bigger. So as we go across to the right, this graph here is getting steeper and steeper and steeper. So the number or the gradient is getting bigger and bigger and bigger and bigger. So maybe it's 1, 2, 3, 4. That's very simple there. Now it's the same thing here, but it's getting a bigger negative number. So then maybe it's like -1, -2, -3, -4. But the actual number itself is getting bigger. It just happens to be negative here. And then we get the exact opposite here. So if our line is getting less steep as we go towards the right, that gradient number will be getting smaller and smaller and smaller. And it doesn't matter whether it's a positive gradient or a negative, we get the same idea. So it's getting less steep. So let's say maybe here it's -4, then -3, -2, -1, and it's heading towards 0. Here, maybe it's 4, 3, 2, 1, and heading towards 0. But it's getting less steep as we go towards the right. So the other scenario we can have, so we can have the gradient gets bigger, the gradient gets smaller. We can also have a constant gradient as well. So if our line is straight or its steepness stays the same, this is described as a fixed gradient line. So the number of the gradient is the same here, 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 here. It'd be the same value everywhere, and it's the same with this one here. So this is constant and positive. This one is constant and negative gradient. Okay, so we've described in general terms how we describe the gradient, but let's actually now get into what the gradient of a graph actually is and how we generate the number that we call the gradient. So the gradient, which we use the symbol m for typically, I have seen in different scenarios different letters used for it, but most commonly the letter m is given to a gradient. And to calculate a gradient, we do the change in y divided by the change in x on the line. So let's actually show you what that looks like. So I've picked two completely arbitrary values on this line. Sorry, it wouldn't matter where I picked them. I should get the same gradient anywhere. And what you work out is we do the change in y divided by the change in x. So you can see here, our y coordinate over here on the right hand side is 4. The y coordinate over here on the left hand side is -1. So I do 4 minus -1 there. So we always put the furthest right coordinate first and the furthest left one second here. So that's why I've done 4 minus -1. So that's just a convention thing, so everyone does the same thing. We could have done it the other way around, but then we'd have to have changed all the rules that we've got so far. So we don't do that. So we always do the one on the right minus the one on the left. We do the same thing for the x. So we do the one on the right, which is 3, minus the one on the left, which is 1. Here, 4 minus -1 is 5. 3 minus 1 gives you 2. 5 divided by 2 gives you 2.5, and it's plus 2.5. So if we don't write anything, we imply it's positive, which makes sense because this line is going upwards as you go towards the right. So that makes sense that it's positive, and the gradient would be the same. It would be 2.5 everywhere on this line because it's a straight line. Now I'll show you a bit later on how we deal with lines which aren't straight and how we measure the gradient of those. But that's enough for now in terms of how we actually get the number that we've been describing so far. So for like this graph here, for example, if we found the gradient here, the number would be bigger than if we found the gradient, say, down here. That's what we're really saying. Okay. So let's come back to our original question that we started this video on. So how would we describe the gradient of this line of best fit using the material that we've covered so far? So we can't actually give it a number, but we can describe what's going on with the gradient of this line. So pause the video, describe what you think you would say about this gradient. Okay, so there are two things that I'm looking for here in terms of describing the gradient. So the gradient is positive. So you can see the line is sloping upwards as you go towards the right. And we'd also say the gradient is increasing. So that means we can see it getting steeper and steeper and steeper and steeper. So those are the two things that I would be looking for in your description there. Okay, so then we're actually getting into what a gradient or the number actually is. So it is the change in y divided by the change in x, I guess between 2 points on your line. And we can pick any 2 points on our straight line and we should get the same gradient, so it doesn't matter. And finally, what is the gradient of this line? Again, pause the video, have a go at this for yourself, see if you can come up with what the gradient is, and then maybe have a think through, does your answer actually make sense? All right, so now you've had a chance to do that. So remember, our gradient is our change in y divided by our change in x. So anytime you see the word delta in physics, that means change. That's our symbol for change. So for our change in y, remember we always use the one on the right first. So we're going to do 2 minus 4. So you can see that's going to generate a negative number. And then we're going to do on the bottom line, it'll be 5 minus 1. So it's going to be minus 2 divided by 4, which gives you minus 0.5 or minus a half. Now, does that make sense? Well, yes, it does, because we've got a negative gradient, and that's good because the line is going downwards as we move towards the right, so that's good. And any points we pick on that line, we'd find the gradient is the same because it's a straight line. So whichever points we picked on that line, we should have got minus 0.5 because it's a straight line type graph. Okay, so I said earlier I would address how do we handle graphs that aren't straight. So we have what we call non-linear graphs. So if we want to find the gradient at a point, what we have to do is actually draw a tangent to the graph there. So you can see that in black here. So this black line is what we call a tangent. And we find the gradient of that tangent. So I've said I've picked 2 points on my tangent. I've called x1, y1, and x2, y2. So we'd do exactly the same thing. We'd do y2 minus y1, x2 minus x1, and we could find the gradient at this specific point here. And if we want to find the gradient somewhere else, we draw a tangent at that other point there. And the further to the right we pick a point, the bigger number we should get for the gradient of our tangent. Okay, so to finish off, as I have been doing and I will continue to do in this video series, I want to finish off by showing you what my notes look like to help promote long-term retention of this information. So we've got the key information that's been in purple throughout the video that we should have noted down. And on the left, we've got my cues that I can use later on to prompt me to retrieve this information on the right later on. So you can see here in the form of this, for this video, my cues are all pictures. So in this graph, the thing that all of these lines of best fit have in common is that they have a positive gradient, which is why there's a P here. The thing that these three have in common is they have a negative gradient. So that's what that's going on here. The thing these two lines have in common is they have an increasing gradient. This is where usually some pedantic student will be like, technically, if a number is becoming more negative, it's actually getting smaller and it's decreasing. And to that student, I would tell them to sod off and stop trying to overcomplicate things. Both of these show an increasing gradient, or if you want to be pedantic, an increasing magnitude gradient. These two graphs show a decreasing gradient, or it's getting less steep over time. These graphs show a constant gradient, and this graph is basically asking you what a gradient is. As you see, what is a gradient? Well, it's the change in y over change in x there. And remembering, in terms of some practical information, you put the furthest right terms first in the calculation. So that's what my notes would look like. And then what I do is when I'm coming back to my next study session, I would cover up the right-hand side of this so I can just see the cues on the left, and I would make myself retrieve that information from my mind to make sure I'm promoting long-term retention of that information. But that's where I'm going to end this video on gradients.